When we write a mathematical proof, we often need to use the definitions of the concepts that appear in the statement. In this video, I will illustrate how we can prove that an example satisfies the definition. I want to prove that the function defined by the equation f of x equals 3x plus 7 is increasing on the real numbers, and I want to do it directly from the definition. This proof is going to be short and simple, and honestly not that exciting, but I'm using it to make a point. I don't need to have learned in advance how to prove that the function is increasing. I don't need to have memorized any template or structure. If I know the definition of increasing, that tells me what the proof should look like. That tells me the structure, and that's all I need. And the same is going to be true for any other mathematical concept. I will begin by recalling the definition of increasing. It says that for every real numbers x1 and x2, if x1 is less than x2, then f of x1 is less than f of x2. This is what I want to prove. I don't know if this is true yet, so I'm going to make sure to make that clear by writing that this is what I want to show, which is often abbreviated WTS. How will this proof go? I need to prove that for every pair of real numbers x1 and x2, this implication is true. Since I need to prove it for every pair of real numbers x1 and x2, I begin by fixing arbitrary values of x1 and x2. When I write this, let x1 and x2 be reals, it means I am fixing them and they're generic, I don't control them, so my proof works for every pair of values. And then I need to verify this implication. In order to prove an implication, I need to assume the if part and hopefully conclude the then part. And what comes here in the middle may be short, may be long, may depend on the case. In this case, it's going to be just a little bit of algebra. And that's it. This is the structure of the proof. So how do I go from x1 less than x2 to f of x1 less than f of x2? Well, in this case, since this is the form of f of x, all I have to do is multiply times 3 and add 7. So if I begin with this inequality and multiply both sides times 3, I get 3x1 less than 3x2. And if I add 7 to both sides, I get 3x1 plus 7 less than 3x2 plus 7. And I am done, because the left-hand side is f of x1 and the right-hand side is f of x2. That's it, I don't need to do anything else. The important lesson I want to take away from this, however, is that I didn't need to memorize that this is the structure of a proof that something is increasing. If I know what the definition of increasing is, then the structure is entirely contained in there. And the same is true for any other definition of any mathematical concept.